Hello and welcome to this video on modeling and solving inverse variation problems. In this video I have a couple examples, just two, but with several parts to them, in which I have a couple quantities that are inversely proportional, or one quantity varies inversely with another, and we'll talk about what that means and how to use that concept of inverse variation to set up a relation between two, or a function between two variables, two quantities, and then answer some questions. Okay. So my first example is pretty simple. There's no units involved or anything, just involves a couple simple variables. And it says, suppose that y, right, this quantity y, varies inversely with, right? I'll talk about what that means on a separate page here in a second. Suppose that y varies inversely with x for just positive values of x. X is greater than 0. And then I'll read part A, and again I'll go into what it means for one quantity to vary inversely with another quantity, or for one quantity to be inversely proportional to another quantity. All right, so part A is, let's find an equation that relates x and y if y is equal to 2 when x is equal to 3. All right. So before we get into that, part A, I'm going to talk about what it means for us to have inverse variation between two variables or between two quantities. Alright, so a quantity, I'll call them A and B. You can call them X and Y if you want. So if I say, or if they say in a problem that some quantity, a quantity A, which is like the Y here, varies inversely with or another way they might say that is a quantity A is inversely proportional to That's another way that might be put. So a quantity A varies inversely with or is inversely proportional to another quantity B, right, a quantity B, if there is a non-zero number which we'll call K, and you'll see this usually called K in most texts you come across. If there's a non-zero number K such that the following equation holds. A is equal to this number K divided by B. Right. And of course here the value of B cannot be 0, right, because you can't have denominators of 0. But I'll put this thing here in a box. This is very important. This is our inverse proportionality model, right? Inverse variation model. And this number K is given a special name. It is always the same number. It's always a constant. So K is called the constant of proportionality. All right, fancy title. An example of a couple quantities that are inversely proportional or vary inversely with one another. An example would be a simple, say, y equals 1 divided by x. In this equation here, y varies inversely with x, because there's this, non-zero number 1. The k in this case is the number 1. And there's a number out there that's not 0 such that y is equal to that number divided by x. All right. And there's a reason that they call this, inverse relationship or inverse variation. If you recall from my last video, if you've been watching, or go out searching for another video on it, we talked about direct variation. And for direct variation, when the value of this k was positive, if one quantity increased, the other quantity increased as well. And if one quantity decreased, the other quantity decreased as well. There was a direct relationship between the two variables. Well, here let's take a look at this equation I have here, the y equals 1 divided by x. Again, when k is positive, you can very easily see that why they're calling this inverse variation. I will make a little table down here relating, we'll see values of x and then the corresponding values of y. And you see when x is, when x is 1, y is 1, right? 1 divided by 1. When x is 2, y is a half, right? It's getting smaller. Half is smaller than 1. When x is 3, y is a third, and that's even smaller. And I can keep doing this, so I'm plugging all sorts of numbers, just not 0, right? Just can't plug in 0 for x. But what we're seeing here is that as x increases, right? As x increases, right, 1, 2, 3, the value of y decreases. So this is where the whole idea of being inverse comes in, right? They're like the opposite. They're the inverse. The same thing would go if I decreased x when 3, 2, 1, y increases, right? So they're going in like the opposite direction. Again, this is when k is positive, right? There's a positive 1 here, the constant of proportionality. You're seeing this inverse relationship between the values of the variables. As one decreases, the other increases. As one increases, the other decreases. Okay, they're going in opposite direction, inverse directions, if you want to say that. All right, but the key to this, though, is this model right here, this setup, this equation. All right, so when they say one quantity varies inversely with another, or when one quantity is inversely proportional to another, that means there is an equation out there like this that you can set up between the two, that one quantity is equal to some constant divided by the other quantity. Okay. So noting that, right, I'll keep that equation up, that model on the bottom here, and go back to my problem. A very simple problem to start, not much of a word problem or anything. There's no units on any of the numbers or anything like that. So they're telling us, right, that y varies inversely with x. Y varies inversely with x. That means that we can write this equation. That means that y must be equal to some constant k divided by x. All right, this is what it means for y to vary inversely with x. And of course, k can't be 0, x can't be 0, and so on. Right? But they're saying x is positive numbers here anyway. So now we just need to finish the equation off. I need to find the value of this constant of proportionality, find the k. All right, and how do I do that? Well, you need to use information that was given to you about y and x to help you find k if you know they're inversely proportional. Well, the only piece of information we were given about y and x was this statement right here. If y equals 2, when x equals 3. Y equals 2 when x equals 3. So that'll help me solve for k, right? Figure out what this k needs to be, this constant of proportionality. So I just, it gives me a value for y to replace with, a value to replace x with, and I'll be left with k, and I'll be solving for k. So y is 2, put that in, 2 on the left equals this number k, this constant of proportionality that I don't know, divided by, and when y is 2, x, the value of x is 3. All right, and then I solve this for k, which would be a simple matter of multiplying both sides by 3. right? The 3's divide out over here, become 1. And I get the value of k, move it to the left here, equals, and then 3 times 2 on the other side, 6. And now I can finish the equation, right? We know that y and x are inversely proportional, so y must be some constant divided by x. And if y is 2 and x is 3, that means the value of k must be 6. All right, so the equation we're looking for here is y equals 6 divided by x. And there's your equation. There's your relationship between these two variables that are, inversely proportional to one another. Wonderful. And now that I have this equation set up, we can answer other questions about the relationships between x and y. And I have just one more here, and then we'll move on to maybe a little more complicated problem. Maybe not that much more, but still throw in some more words and more units and stuff. Part B, now that I know this, find y when x is 4. So that's real simple, I hope. Pop in 4 for x and figure out what y needs to be. So that gives me y equals, the numerator, that k is 6 over here divided by, and then x is 4. Wonderful. And there you go, y equals 6/4. Now, of course, I'd like to reduce this, right? The 6 and the 4, the numerator and denominator, have a common factor of 2. So that's 2 times 3, that's 2 times 2. This is reducing to 3/2. Okay, so there's the simplified fraction, right? 3/2. Or if you want to write it as a decimal, it's 1.5, that's 1.5. Or write it as a mixed number with 1.5 after it, But I'm going to leave it like this. This is fine. All right, and very simple. And this is like most problems. Once your model is finished, once your equation is finished, showing you the relationships between variables, usually most other questions that get asked are pretty simple to solve, pretty simple to answer. Okay. So now that hopefully now that we know that what this means, what it means for one variable to vary inversely with another one, let me go into, now here's an application problem involving the vibration of a string under constant tension. All right, so a little more wordy this one, but it says here, the rate of vibration in oscillations per second. The rate of vibration, denoted by variable v, the rate of vibration of a string under constant tension varies inversely with, there are those words again, varies inversely with, or, is inversely proportional to the length of the string, denoted by a variable L, represented by a variable L. So it's like a guitar string they're talking about here, So if one end's held down, the other end's held down, and here's a string, let's say this is a string, and it's under constant tension, meaning pressed down on this end, held down on this end, held down on this end with the same force, right? And it gets plucked, say the string gets plucked, and then it vibrates, oscillates up and down, right? And it might even do a little wave thing, but it goes back and forth, right? Oscillates back and forth, the string. And when it starts up, it goes basically every time it goes up down, every time it goes up down, that's one oscillation, right? Or left right here, every time it goes up down, that's one oscillation. So there's one oscillation, one oscillation, one oscillation, and so on. That's what this problem is talking about. All right, again, just think of a guitar string or a banjo string being plucked. Right, that string is under constant tension and it starts vibrating when you pluck it. All right, so before I even get into the problem, I'm going to write a little equation here. All right. They're telling me that this rate of vibration, V, varies inversely with the length of the string, how long it is, right? So here's an equation that we know of right now. Right now, it's not complete because I don't know the value of k, but I know that the vibration of the string, the rate of vibration, varies inversely, or is inversely proportional to the length. So that means there's some number k, right? Some non-zero number k. This is a constant here, the constant of proportionality, divided by L. Right. So this is again saying that V varies inversely with L. The rate of vibration varies inversely with the length of the string. Okay. So just like before, I need to know what this is to complete the equation. I need to find k. I need to know what that is to complete the model, and then I'll be able to answer whatever other questions they may have. Alright, so now I'm going to read part A. Alright, so if a string is 30 inches long, and that 30-inch long string vibrates at this rate, right, this 500 times per second, let's then find a function or an equation that relates the rate of vibration v to the length of the string L. Well, I already have part of it here. Again, I just need to find k. Here's an equation that relates v and L, the rate of vibration and the length. I just need to find this k. And just like the last problem, when I was trying to set up this equation that relate the two variables, we're looking for that constant of proportionality. I need to use some information that was given. Well, they told us that a 30-inch long string vibrates 500 times per second. They're telling us when L equals 30, right, because again the length is in inches, right? Let's just say the length is in inches here. So when the length is 30 inches, when L equals 30, the rate of vibration vibrates at a rate of 500 times per second. V equals 500, right? Oscillations per second, or times per second. That was the units given to us earlier. So you can see how, just like the last example earlier in the video, I can use this information to find this k and then complete the equation. Alright, so let's pop those in. V is 500, so I've got 500 on the left, equals this k that I don't know, divided by, and then the length of the string is 30 inches, so I put 30 down there. And I'm solving for k, and to get k alone here, I would simply need to multiply both sides by 30, right? It's already being divided by 30. To undo that, I multiply by 30. And we're getting the value of k. I'll pop that on the left here. Right, this side's k, and then this side would be 15,000. Right, 30 times 500. And now I can finish the equation. Right? So the equation is the rate of vibration equals 15,000 in the numerator, that's the k, divided by the length of the string L. Right? So there, I'll put that in a box. There's a v written as a function of L, right? Where a relationship between v and L, and we're saying v is inversely proportional to L. Right? V varies inversely with L. As L increases, v would decrease, and vice versa. As v decreased, L would have to increase, and so on. Right? They have to go in opposite direction, inverse direction. Wonderful. And then just like the last problem, the first example I did, now that I have this equation relating v and L, I can answer some questions. And I've only got one more here, so I'll keep this up. What is the rate of vibration of a string that is 50 inches long? So the question is about what is the rate of vibration. So what we don't know here is the value of v. Remember, v stood for the rate of vibration in oscillations per second of a string that is 50 inches long. So that's giving us the length, right? The value of L is, I'll just put 50, right? Because we're assuming L, we know L is in inches. So this is again a very simple matter. I'm replacing L with 50, and trying to find, what does V need to be, and then I'll also answer the question in a nice complete sentence and have units on my numbers so that they have meaning, so that they make sense with the problem. The way you should answer any word problem in complete sentences with units on the numbers so that they have meaning. Alright, so I pop those in. The V, right, I do not know. So that's still V equals, the constant of proportionality was 15,000 here, divided by, and then the L is 50, right? The length of the string is 50 inches long. Simplify these, right? This is all well and good, but you can divide that pretty easily, right? V would be equal to, they have a factor of 10, you get rid of those, and then you just got 5 going into 1500. So that would be 300, right? 300. So that's the solution of this equation here. But again, it doesn't mean anything until I throw units on it. Until so the way I'm going to write the answer to this question, I'll do off to the side here, is again with a nice complete sentence. So what is the rate of vibration of a string that is 50 inches long? The rate of vibration is, and then what was rate of vibration? That was this V is 300. And what were the units on V? That was in oscillations per second, right? It vibrates back and forth 300 times per second. And that's, again, if I was given this in a homework exercise or as part of a test, this is how I would be answering that question. All right, and do you see the inverse proportionality here, the inverse variation? Notice how earlier they mentioned when the string was 30 inches long, the vibration was 500 times per second. You see how the length increases to 50. The length increased, the vibration rate decreased. It went from 500 to 300. That's it. They're going in inverse directions. Length increased, so the rate of vibration decreased. So there's definitely an inverse relationship between V and L here. So hopefully that made all sorts of sense. And as I like to say at the end of these videos, please try to do the best you can to learn the material and understand everything. I'll understand the material before you go looking for help. Do it on your own before you go looking for help. Because I have found that people who put in the time and the effort to learn material and understand it on their own tend to remember that material for a lot longer and have a better recall of it. So read the material, of course. Read through the author's examples. Perhaps even work on some of the author's examples before you see how the author did it, and then compare your work to the author's and see if you can learn from some mistakes there. Obviously, practice tons of exercises, practice problems, and look up solutions to those when they're made available so you can check your work, check yourself. And don't give up on a problem after the first attempt at it. Usually there are several approaches that'll work in a math problem. So if after several approaches, several attempts at a problem, you're still not getting how to do it, still not understanding the material, perhaps you should read the material again, maybe even a third time, more slowly, more deliberately. Take notes. And two, if you're working on some problems, you probably have a better understanding as to what the author is asking of you, what the author wants from you. So that'll keep in your mind what to look out for when you read the material again. And perhaps you'll even catch some things on the second or third read-through that you didn't on the first time. And it'll make working on the problems that much easier. But if after that, if after several read-throughs of the material and several attempts or approaches at the problems, you're still not getting it, it's not a sign of weakness whatsoever to go looking for help. That is what other people are there for. So ask a teacher, a tutor, a friend, someone in your class who you know knows the material well and is willing to help. Look for supplemental materials online. There's loads of it out there. Look for videos online. There's lots of math videos out there too, plenty, like this one, and I'm sure there's loads out there that are better than this one, better than the ones I put out, and you can easily find them. But just, stay persistent is all I'm saying. Keep practicing, keep at it, don't give up. And I think the hardest thing too is to keep a positive attitude about the subject. I know it's easier said than done, but if you go in with an open mind, thinking I'm going to read this material, I'm going to practice this stuff, and I'm going to enjoy learning it, I'm going to learn something, I'm going to take something away from it and use it in my life, in my class, at work, whatever. Have a positive attitude, perhaps even have fun with it. It's amazing the difference that a change in attitude and an adjustment in mindset can make in the learning experience. Alright, so just be persistent, stay positive, keep practicing, just don't give up. And I know you can get it. And thank you very much for watching.